So, dear students, to, today we are discussing ninth unit. Unit 9. Unit 9. Unit 9. Characteristic roots and characteristic characteristic roots and characteristic vectors. Characteristic roots and characters. CV means characteristic vectors and Cayley-Hamilton theorem. CHD and CHT. CHD means Cayley-Hamilton theorem. Cayley-Hamilton theorem. Concepts. 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 Characteristic equation of a matrix. Characteristic. Characteristic roots of a equation. Characteristic equation of a characteristic equation of a matrix. Characteristic equation of a matrix. Definition. Let A Aij means ith row, jth column, meaning Aij. Be any n row square matrix square matrix square matrix we enrolled square matrix and a lambda an indeterminate lambda an indeterminate an indeterminate indeterminate then the matrix A then the matrix then the matrix A minus lambda I A minus lambda I equal to 0 is called characteristic matrix of A is called characteristic characteristic matrix of A. Characteristic matrix of A. The roots of the equation. Roots of the equation. Roots of the equation. Roots of the equation. A minus lambda I. A minus lambda I equal to 0 are called characteristic roots or characteristic values are called roots are called characteristic roots are characteristic values are eigenvalues or eigen is the German word. Eigen means proper or characteristic. Eigen values. Eigen values. Next, characteristic vectors of a matrix. Characteristic vectors of a matrix. Of a matrix. Characteristic vectors of a matrix. Characteristic vectors of a matrix. If lambda is a characteristic root, if lambda is a characteristic root, characteristic root of n cross of n cross n matrix, n cross n matrix, then a non-zero vector x, then a non-zero vector x non-zero vector x such that ax equal to lambda x. This can be written as ax minus lambda x equal to 0. So take x as common. A minus lambda x that equal to 0, where x equal to vectors x1, x2, x3, x3. Is called a is called a Characteristic vector. Vector. Characteristic vector or eigenvector. Eigenvector of a corresponding to the characteristic lambda of A, corresponding to the characteristic root or lambda corresponding to the characteristic root characteristic root lambda. Word production. Example. Determine the characteristic root of the matrix A. Determine the characteristic characteristic roots of the matrix A. 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 1, 2, 3, 0, 4, 2, 0, 0, 7, 0, 0, 7. Solution. Characteristic equation of a matrix. Characteristic equation of a matrix. Matrix A minus lambda I equal to 0. A minus lambda I equal to 0. Where I equal to here, I is the unit matrix. I use unit matrix. The unit is a unit matrix. Here A equal to 1, 2, 3, 1, 2, 3, 0, 4, 2, 0, 4, 2, 0, 0, 7 minus lambda. I means unit matrix. Depends upon order of the matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. That equal to 0. That implies 1 minus lambda, 1 minus lambda 2, 3. Second one, 0, -4 minus lambda, 2. Next, 0, 0, 7 minus lambda, that equal to 0. Then find the determinant with respect to first column. So 1 minus lambda minus lambda. Lambda. By deleting respect to row, respect to column, what you will get? -4 minus lambda, 2, 0, 0, 7 minus lambda, that equal to 0. That means here, that implies 1 minus lambda, AD minus BC, AD minus BC, 4 plus lambda, minus minus plus, minus again minus will take from lambda minus 7, that equal to 0. That means lambda equal to 1 comma -4 comma 7. So these are the roots. Determine the characteristic. Example 2. 10 marks long answer type question. This is determine the characteristic roots. CR means characteristic roots and the corresponding characteristic vectors and corresponding COR means corresponding characteristic vectors. CB means characteristic vectors of the matrix of the matrix of the matrix of the matrix matrix A equal to 6 minus 2 2 6 minus 2 2 minus 2 3 1 minus 2 3 minus 1. Next 2 minus 2 3 2 minus 2 3. So solution. So characteristic equation of a matrix A. The CE means characteristic equation of the matrix A. Of the matrix A. Of the matrix A is mod A minus. Before we did same thing. A minus lambda I equal to 0. Equal to 0. That implies 6 minus lambda minus 2, 2, 3 minus lambda minus 1, 2 minus 1, 3 minus lambda, that equal to 0. After after simplification, we'll get lambda equal to 2, 2, 8, 2, 8. So corresponding vectors corresponding to corresponding eigenvectors at case 1. Eigenvectors, vectors at lambda equal to 2. Who are there? One is we are doing. At lambda equal to 2. So that means what we have equation A minus lambda I equal to x equal to 0. So in place of lambda, we'll substitute A minus lambda. Lambda means 2i into x, that equal to 0. That means A means 2i. Equal to, that implies A minus 4 minus 2 to A 6 minus 2 now. That means A means, so get 4 minus 2, 2 minus 2, 1 minus 1, 2 minus 1, 1, 2 minus 1, 1. It equal to x. X means x1 comma x2 comma x3. That equal to 0 means 0 comma 0 comma 0. Right. So R1 gives shuffling R1 implies and implies R2. So we are changing minus 2, 1, minus 1, 4, minus 2, 2, 2, minus 1, 1. It equal to x1, x2, x3. That equal to 0, 0, 0, 0, 0, 0. So R2 gives, so here elementary row operations. R2 gives R2 gives R2 plus 2R1. R2 plus 2R1. R3 R1 gives R3 plus R1. R3 plus R1. The coefficient of this matrix is the coefficient of the coefficient of these equations is these equations is of rank 1, is of rank 1, rank 1. So these equations possess these equations possess these equations possess 3 minus 1 that equal to 2 linearly independent solution. And solution. So the equation can be written as the equations can be written as the equations can be written as 2x1 plus x2 minus x3 equal to 0. Put x1 equal to minus 1 minus 1 x1 equal to minus 1. X2 equal to 0. X3 equal to 2. X3 equal to 2. So x1 equal to minus 1 comma 0. X3 equal to x3 equal to 1 to 0 to 0 are two solutions of this equation. Two solutions of these equations. Of these equations. So the characteristic similarly Similarly, x3 equal to 2 minus 1, 1. So is an eigenvector, is an eigenvector eigenvector corresponding to lambda equal to 8. Corresponding to lambda equal to 8. Corresponding to lambda equal to 8. The Cayley-Hamilton theorem, most important for long answer type. Question formation is state and prove Cayley-Hamilton theorem. Cayley-Hamilton theorem. Hamilton. Hamilton theorem. Statement. Statement. Every square matrix satisfies every square matrix every square matrix satisfies its own characteristic equation. Own characteristic every square matrix satisfies its own characteristic equation. Proof. Most important proof. Suppose A is a square matrix of order n. A is a square matrix order n. So order n. Here, equation of the characteristic A minus lambda I. A minus lambda I equal to minus 1 whole power n lambda n plus A1 lambda n minus 1 plus A2 lambda n minus 2 plus so on plus an. Then we prove that the matrix equation, then we prove that the matrix equation matrix equation matrix equation matrix equation matrix equation xn plus a a1 xn minus 1 x n minus 1 plus a2 xn minus 2 n minus 2 plus so on that equal to 0, that equal to is satisfied by a is satisfied by a satisfied by an plus a1 an minus 1 plus a2 an minus 2 plus so on plus an that equal to 0. Since the elements of a minus lambda I since the elements of a minus lambda I are since the elements of a minus lambda I are at most of the first degree in lambda are at most of the first degree of in lambda. First degree first degree of lambda. First degree of lambda. First degree in lambda. First degree in lambda. The elements of adjoint the elements of elements of the elements of adjoint a minus lambda I a minus lambda I are ordinary polynomials in lambda are ordinary polynomials in lambda polynomials in lambda of degree n minus or less of degree n minus 1 or less or less. Therefore, adjoint a minus lambda I a minus lambda I equal to B naught lambda n minus 1, n minus 1 plus B1 lambda n minus 2, n minus 2 plus so on, plus so on. B n minus 2 lambda n minus 2 lambda plus Bn minus 1, Bn minus 1, where B naught, B1, n minus 1 are matrices of the type where B naught, comma B1, from Bn minus 1 are matrices, matrices matrices of the type n cross n, of the type n cross n, of the type n cross n, the type n cross n, the type n cross n, whose elements are functions of, whose elements are whose elements are functions of functions of whose elements are functions of Aij's, Aij's. We know that WPT means we know that we know that A minus lambda I, A minus A minus lambda I, A minus lambda I into adjoint A minus lambda I that equal to modulus of A minus lambda I into I, to I. So A minus lambda I that equal to B naught into B naught lambda power n minus 1 plus B1 lambda power n minus 2 plus so on Bn minus 1 Bn minus 2 plus Bn minus 1 n minus 1 no, n minus 2 lambda that equal to minus 1 whole power n minus 1 whole power n lambda power n plus A1 lambda power n minus 2 lambda power n minus 2 plus so on An an that equal to I to I. So comparing the coefficients of like powers of lambda, comparing them. Coefficients of comparing the coefficients of like powers of lambda. Like powers of lambda. Like powers of lambda. On both sides. On both sides. On both sides. We get -1 B naught that equal to -1 whole power n into I. AB naught minus IB1 that equal to -1 whole power n A1I AB1 minus IB2 that equal to -1 whole power n -1 whole power n -1 whole power n A2I so on ABn -1 ABn -1 that equal to -1 whole power n -1 whole power n ANI so A equal to C1 C2 comma C2 etc. Cn 1 cross n. Multiplying these successively by multiplying these successively by successively by an -1 etc. I and adding we get adding we get A power n -1 0 equal to minus 1 whole power n minus 1 whole power n an an plus a1 an minus 1 n minus 1 plus a2 an minus 2 n minus 2 plus so on an 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 therefore an comma a1 an minus 1 plus a2 an minus 2 plus so on an I equal to 0 equal to 0. Hence proved. This completes the proof of theorem. This completes proof of the theorem. This completes proof of the theorem. So, based upon this theorem, one example. Example 9.4.2. 9.4.2. Important 10 marks question. Find the characteristic roots of the equation. Find the characteristic roots of the equation. Characteristic roots of the equation. Roots of the equation. Roots of the equation. Characteristic roots of the equation. A equal to 2 minus 1, 1. 2 minus 1, 1. So minus 1, 2. Minus 1. 1 minus 1, 2. 1 minus 1. And verify that it is satisfied by A. And verify CHT means Cayley-Hamilton theorem. And hence A inverse. And hence obtain A inverse. Obtain A inverse. Obtain A inverse. So do it as homework this. Most important for 10 marks question, long answer time. Okay. So thank you very much. I'm leaving. We'll meet tomorrow.